This is Peter Newman, and today I'm looking at a sheet metal weldment that has tab and slot weld design to make a sandwich, and that's mid-surface geometry has been prepared in the CAD file, and we'll see what that looks like now. And there's basically two sheets at the midplane and several spaces that have tabs. The tabs would go through slots and be welded, but as a finite element model, the slots have been deleted and the tabs cut off at the mid-surface where they will be connected by contact in this model. So in mechanical, we'll open that up, and now we see in mechanical and the two bodies that are 4.76 millimeters thick are these two, and the three bodies on the inside are 3 millimeters thick. So we're going to create, say, a connection group, and it'll be all bodies, and any bodies with a value of an edge closer than 0.01 millimeters will be found and create automatic connections. And I need to tell it to don't look at the face-to-face, but do look at the face-to-edge, and we'll find some contacts this time. So create automatic connections, and now we have eight contact regions, and those are all shown in this list. One of the things we'll do with the contact regions is we'll change it to a formulation that makes it easy to see the contact elements, and that formulation is called MPC. We're going to now assign a mesh size, so we'll insert sizing for all the geometry, and that sizing is going to be a default of 5 millimeters. So we can go ahead and mesh that now. So there's our mesh, and if we look in closely, we see that the mesh has changed the shape, and that's because there's something called mesh defeaturing as one of the advanced, it's one of the sizing operations, automatic mesh-based defeaturing. We want to turn that off and update the mesh, and we'll see that the tabs are going to be left square the way they were, and that's what we want. We've got the contact regions, so if we go ahead and apply a load and a boundary condition, maybe put a couple of edges here to have fixed support, and maybe pick this edge here to have a load, some kind of a force, say 500 newtons, and we can then solve this model. One of the things we could have done before solving is generate or insert the contact tool and generate initial contacts, and that would always be advised before using contacts. And what we'll be looking for is to see that the contact tool shows that all the contacts are closed, and we Don't want to see any open contacts if they're bonded. So that should have been done before we solved, but we did solve with no problem. We're going to throw in a couple of results and evaluate those. So the deformation is now showing that the end of that leg is penetrating through the thing, but we are looking at 130 times exaggeration, and if we plot that on a true scale, it doesn't look so bad. But we could add a frictional contact so that that spacer did not penetrate that. The other thing we can look at is this stress, and we can maybe get more visibility on seeing that the welds are carrying the load from one plate to another. Another result, two ways to look at the contacts here. If we click on Solution Information and Graphics, the MPC elements, the contact elements that represent the weld between the tab and the plate, are shown in red here. So that's one way to visualize that the contacts are where we expect them to be, is to visualize the MPC elements. The other thing we can do is insert the contact tool into the results and evaluate that. And in this case we can see all of the contacts are sticking, which is a good way to be. So that's another validation that the contacts are behaving the way we want them to. That's probably a good place to end the video.